Thanks for watching my video today. Let's see our another interesting integral, then is Dirichlet integral. Okay, then is integral from 0 to infinity sin ax upon x dx for or a is greater than 0. Okay, a is greater than 0. Okay, let's state our condition in the last. Okay, now let I is equal to if you put here, if a is greater than 0, then you get some value. If a is negative, then you get some value. If a is 0, then sine of 0 is 0, right? Now let our integral to be I, which is integral from 0 to infinity sin ax upon x dx. Okay, now consider integral. Now we are going to prove our Dirichlet integral using double integral. Okay, some of them may try to prove this integral by Feynman technique also. Okay, then is in differentiation under the integral sign. Okay, then is also another way to approach. So here is my way to approach. Okay, so using double integral. Now consider integral I1. Okay, then is double integral from 0 to infinity of e to the negative xy sin ax dx dy. Okay, then is now I'm going to take x. Okay, so integral from 0 to infinity sin ax. Now integrate this or y part, so integral from 0 to infinity e to the negative xy dy dx. Right, therefore I1 is integral from 0 to infinity sin ax. If you integrate this, you will get e to the negative xy upon negative x dx from 0 to infinity. So if n is infinity, this will be 0. If n is 0, this will be 1. Then that means 1 over x, right? So our integral from 0 to infinity sin ax upon x dx. So we get our I1 from this double integral. We get our integral to be evaluated, right? This is our integral I again, right? So that means our integral I is same as this double integral. Okay, again, now let's evaluate the real. Okay, let's evaluate for this double integral now. So I1 is equal to double integral. Okay, integral from 0 to infinity, integral from 0 to infinity. Now I'm going to take out this y like a constant. Now I'm going to integrate x part. Okay, then e to the negative xy sin ax dx times dy, and we know that now applying this one, integration of e to the ax sin bx dx is nothing but e to the ax upon a square plus b square times b cos, right, b cos ax minus a cos a sin bx. Okay, applying that one, then you get I1 is equal to integral from 0 to infinity e to the negative xy upon y square plus here, or a is y, right, or b is a again, so y square plus a square times a cos ax minus y sin ax from 0 to infinity dx, right? So I1 is equal to integral from 0 to infinity. If you put infinity, so this short term will be 0. If you put 0, this will be 1. But if you put here x equal to 0, so cos 0 is 1, right, and sin 0 is 1, then you get only a, right? So then is a upon y square plus a square dy. So this is easy to evaluate. So a times integral from 0 to infinity dy by y square plus a square. Then we know that integration of dx upon x square plus a square is nothing but 1 over a tan inverse of x over a, right? Then is our formula. Then you get a into 1 over, here is this a again, tan inverse of y. Okay, this will be y actually, y over a. Okay, cancel out, then you get tan inverse of, if you put y equal to infinity, so tan inverse of infinity minus tan inverse of 0, which is infinity is nothing but pi by 2 minus 0, which is equal to pi by 2. Okay, so our integral, this or original integral, this one is nothing but pi by 2. Okay, so if now let's take for the condition for this a, okay, the value of a. So integral from 0 to infinity sin ax upon x dx is pi by 2 if a is greater than 0. Okay, if a is greater than 0, then you get pi by 2. If a is 0, then you get 0, right? Sin 0 is 0, of course. If a is negative, then you get what? Sine of negative ax is nothing but negative times sin ax, right? Therefore negative times sin ax by x is pi by 2, right? So this integral work for integral like this. Now if you substitute integral from 0 to infinity, if you substitute a equal to 1, so sin x by x is pi by 2. Okay, and again integral from 0 to infinity sin 2x by x dx. If you put a equal to 2, then you still get pi by 2. Okay, so if you put any value for this a, then you still get only pi by 2. Okay, and if a is 0, so the integral will be 0. If a is negative, then it will be negative pi over 2. So this is for the condition. Okay, so our Dirichlet integral is nothing but pi over 2.